Welcome again. Let's continue with the next session of the SRS unit, that is a developing use cases. So, what do you mean by use cases? It is a stepwise refinement manner with each step adding more details. So, in that each step we have to add some more details regarding to develop some software. So, in this approach allows uses, that is use cases, to be presented at the different levels of abstraction, mainly actors and goal, main success scenario, failure condition and the failure handling. Let us see one by one what is involved in these 4 steps. Actors and goal. The actor goal list enumerates the use cases and specifies the actor for each goal. It gives scope and overall view of what it does, means what is the overall content or what is the actors to achieve, who is the actor to achieve that goal is known as the actors and goals. So, you have to list actor and you have to list the goal to achieve some specific task. So, that is the actors and goal. Next is main success scenario. So, it says the system behavior of each use cases is specified. So, main success, you get the success, you have to specify the behavior of that particular system in which the case is specified. That is the next is failure condition. You have to once the success scenario is listed, all the possible failure condition can be identified. So, if you are not identified the failure condition, the project may get failure. So, that is what once all the success scenario is listed, you have to identify what is the failure condition or the possible failure condition. Next is how to handle the failure. So, determine what should be the behavior under different failure condition will often identify new business rule or new actors. So, you have to change the rules and you have to change the actions to build to more handle with that failure. So, you have to check or you have to change the behavior of that particular failure. So, that is what it is one of the useful factors to identify the failure more consistently. So, that is what the determines the behavior under different failure condition for getting the new business rules or by introducing the new business rules or the new actors. Next we will see the approaches or analysis activities regarding these 4 steps. Step 1, identify the actors and their goal and get an agreement with the concerned stakeholders as to the goals, scope and overall view of what the system capabilities are. So, as I said in the actors and goals, you have to identify the scope and overall view of what it does. So, in the same way you have to identify what is the goal and you have to take an agreement with the concerned stakeholders to more secure or more confident. So, that is why it is to be understood or it is to be get an agreement with the concerned stakeholders regarding that goal. Second, understand and specify the main success scenario of each use case, giving more details about the main functions of the system, list all the use cases to be explained. So, you have to mention all the use cases main success scenario to be listed. So, what is to be done, what is the thing happened to cause an error or what is the failure condition. So, all the things to be and what is the main function of the system. So, all the things to be listed. So, it may and listed and it may be explained. So, that is what some of the useful factors to avoid the error. And the step 3, after agreement of main success scenario and main steps and it is execution are specified, then the failure condition can be examined. So, once the this thing second point main success scenario to be listed, so it may move to the condition. So, what is the failure condition to be examined? So, after the main success scenario and the main steps in its executions are specified. Finally, what should be done for these failure condition? Many new business rules and how to deal with these scenario are uncovered. So, if you want to avoid the error or if you want to avoid the failure, you have to introduce the new business rules of how to deal with these scenarios are uncovered. For example, if you have failed in one subject, so for the next time you have to overcome the failure. So yaka failure aitu, yake a subjectal failure ade. So new innovation or new rules of studying introduce ಮಾಡಿದಾಗ you may get success. So that is what the fourth step. Then other approaches, what are the other approaches for this analysis? Analysts act as a consultants who play an active role of helping the clients and users identify their needs. So here role and or actors and goals is nothing but some of the analysts may act as a consultant, and he acts as a he plays an active role regarding the helping between the clients as well as the user to identify their needs. So what is the need actually, or what is the need of the customer? So the consultant may help in each sector. So basic principle used in analysis is the same as in complex task. So what are the basic principles or basic tasks that we have seen in this analysis? One is divide and conquer, second is state and projection. So as you all know that divide and conquer means you have to partitioning the problems into sub-problems, and after all the sub-problems you get the answer, then you have to combine with the simple one total problem. So in the same thing, the partition of the problem into sub-problems and then try to understand each sub-problem and its relation to other sub-problems is an effort to understand the total problem. So you are too hectic or it is more complex to resolve the total problem in a single shot. So that is what you have to divide, or you have to partition the problems into sub-problems, then to understand the relationship between the sub-problems and to you are getting the solution of that sub-problems, then you have to combine with the total problem. So that is one of the approach to get it more error free. So complex task iddaga ee tara ಒಂದು approach na ಮಾಡಬಹುದು. Then state and projection. State of a system represents some condition about the system. Projection ಅಂತಂದರೆ it defines multiple points of the view. ಸೊ ಎರಡು ಬರುತ್ತೆ ಇದರಲ್ಲಿ, ಒಂದು ಸ್ಟೇಟ್ ಅನ್ನೋದು ಒನ್ ಇಸ್ ಪ್ರೊಜೆಕ್ಷನ್. ಸ್ಟೇಟನ್ನೇ ಒಂದು ಕಂಡೀಷನ್, ಒಂದು ಸಿಸ್ಟಮ್ನ ಕಂಡೀಷನ್ನ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡುತ್ತೆ. ಪ್ರೊಜೆಕ್ಷನ್ ಅಂತಂದರೆ ಮಲ್ಟಿಪಲ್ ಪಾಯಿಂಟ್ಸ್ ಆಫ್ ವ್ಯೂ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಒಂದು ಫೀಲ್ಡಲ್ಲಿ ದ ಸೇಮ್ ಸೆಕ್ಟರಲ್ಲಿ ಡಿಫ್ರೆಂಟ್ ಪಾಯಿಂಟ್ಸ್ ಆಫ್ ವ್ಯೂ ಬರುತ್ತೆ, ಡಿಫ್ರೆಂಟ್ ಪಾಯಿಂಟ್ಸ್ ಆಫ್ ಸಜೆಷನ್ಸ್ ಬರುತ್ತೆ. ಆದರೆ ವಿಚ್ ಈಸ್ ಮೋರ್ ಸೂಟಬಲ್ that suggestion can be used. So that is what the projection. The system is defined from multiple points of view, but in future situation based on study of present trends. So according to this trend, which is more apt, which solution is more apt, that is to be selected. So that is what the divide and conquer and state and projection. Next we will move to the data flow diagram. So you know that DFD is also called as the commonly used in during problem analysis, and it flows, the flow of data is known as a data flow diagram. So throughout the system, how the data should be flowed, or what is the first step, what is the second step, the flow of data. The flow of data is nothing but the data flow diagram. So this is the symbol which we are using to represent some data flow diagram. So and this is a symbol is a flow of data, so used to connect the process of each other to sources or sinks to arrow which indicates, head indicates the direction of the data flow, and so this arrow indicates the in which side the data to be flow, and this is a symbol is known as a process. It performs some transformation of input data to yield output data. So what is the input and what is the output? So that represents the process, and this rectangle indicates the source of sink, that is the external entity, the source of system inputs or sink of system output. So input and output anna represent ಮಾಡೋದಕ್ಕೆ, so this rectangle will help, and this arrow mark will said that the data store. So a repository of data, the arrow head indicates net inputs and net outputs to be stored. Where the data is to be stored, it will be seen in this arrow mark. So this is what the some of the representation regarding the data flow diagram. And here is one example regarding the DFD of a system that pays worker. So this is what the get employee file, weekly pay, overtime pay, deduct taxes and issue paycheck, and these are all the process. So how it is to be done by the use of a worker and the worker these things. So get employee file. So in the initial stage you have to know the employee ID or the employee file to know whether he is working completely in a month or overtime ಏನಾದರೂ ವರ್ಕ್ ಮಾಡಿದಾನ ಅಥವಾ what is the salary he get until all the days he had worked, and in which basis he get salary, pay check through na athwa cash through na. So this is what the pay workers DFD. Yes, this is in this system it completely indicates the record of every employee, his name, his address, his phone number, email ID, everything is to be stored in this employee file, and it is to be represented through the employee ID. Every worker is represented by, not by his name, by his employee ID. And weekly pay. So what is the pay of weekly? So for example, in a month there are 4 weeks, every week what is the pay he get, and overtime pay. So if he works more than 8 hours or more than 12 hours, and he get overtime pay regarding that hours. So how many hours he work. So this is what the weekly pay for regular hours, and this pay will be of overtime hours. So it is to be also calculated the overtime rate, and including weekly pay plus overtime pay, and you have to deduct the tax. So then he will get the net pay. So according to the company records, he will issue the check. So this is what the his actual net salary, and this is to be checked by the worker. So this is what the data flow diagram or the flow of data for that particular task. And next is ER diagram or the entity relationship diagram in software engineering. As you all studied in the DBMS, that is the ER diagram. So ER means entity relationship, entity anta barutte, attribute barutte, then primary key, foreign key. So in this concept you have studied everything regarding the entity relationship diagram in according to the DBMS. Here also in software engineering also we have used this concept, that is ER diagram. So this diagram are used in software engineering during the planning stages of the software project. They help to identify different system elements and their relationship with each other, and it is often used as a basis of data flow diagrams or DFT that are commonly known. ಸೊ ಯಾವುದೇ ಒಂದು ಸೆಕ್ಟರ್ಸಲ್ಲಿ ಸಾಫ್ಟ್ವೇರ್ ಪ್ರಾಜೆಕ್ಟಲ್ಲಿ ನಾವೊಂದು ಫ್ಲೋ ಆಫ್ ಡೇಟಾ ಅಥವಾ ಡೇಟಾ ಫ್ಲೋನ ತೊಗೊಳ್ತಿದ್ದೀವಿ ಅಂದರೆ ಒಂದು ಎಂಟಿಟಿಗೂ ಇನ್ನೊಂದು ಎಂಟಿಟಿಗೂ ಇರ್ಬೋದು, ಅಥವಾ ಒನ್ ಅಟ್ರಿಬ್ಯೂಟ್ ಟು ಅನದರ್ ಅಟ್ರಿಬ್ಯೂಟ್ಗೆ ಯಾವ ಥರ ರಿಲೇಷನ್ಶಿಪ್ ಇರುತ್ತೆ, ಸೊ ಅದನ್ನು ಐಡೆಂಟಿಫೈ ಮಾಡೋದಕ್ಕೆ ನಾವು ಇ ಆರ್ ಡಯಾಗ್ರಾಮ್ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಇನ್ ಸಾಫ್ಟ್ವೇರ್ ಇಂಜಿನಿಯರಿಂಗ್. ದ ಸೇಮ್ ಥಿಂಗ್, ಇ ಆರ್ ಡಯಾಗ್ರಾಮ್ symbols and notation as you all studied in the DBMS, everything is same here. So this rectangular shape, it indicates the entity, and this oval is indicates the attribute, and this diamond shape indicates the relationship, and this double rectangular is indicates the weak entity, double oval is indicates the multi-valued attribute, and this is a weak relationship. Yes, there are mainly three basics elements in the ER diagram. One is entity, attribute and the relationship. So there are more elements which are based on main elements, that is the entity, attribute, relationship alle main concentrate irutte, athwa it is all depend on these three factors especially. So there are weak entity, multi-valued attribute, derived attribute, weak relationship, recursive relationship, cardinality and ordinality. Two other notations are used in the diagram to further define the relationship. Yes, as you all know that cardinality ratio 1:n, m:1, 1:1. So these are all the cardinality ratio, means how the relationship is going on. So that is what the cardinality. For example, one employee can belongs with a single branch. Yes, Alva, I cannot manage the 2 branches at a time because I am an employee of computer science. I may teach, or I may belongs to, I can teach more than a one branch, that is 1 is to n. But I may belongs to the only one department, that is a computer science, that is 1 is to 1. So, this is what the cardinality ratio. Yes, here are some of the definition regarding the some elements, that is attribute, multivalue, derived, relationship, cardinality and ordinality. So, what do you mean by attribute? Attribute is a property or a trait or a characteristic of an entity, relationship or any other attribute. And multivalued means more than one value or more than one attribute is known as a multivalued attribute. Derived means the attribute based on another attribute. This can be found rarely in ER diagrams. For example, for a circle, the area can be derived from the radius. Yes, so this is what the example. In this sectors, we have used the derived attribute concept. Relationship means it describes how entity interact. So, this is what the relationship. Cardinality is nothing but these two further defines the relationship between the entities by placing the relationship in the context of numbers. As here there is some example. One account can have multiple contacts. The relationship in this case 1 to many model. So, as I said, one employee can belongs to the one department, that is 1 to 1. One employee can teach more than one branches, means 1 to many. One employee can teach many more students, means 1 to n. So, this is what the cardinality ratio. And what do you mean by entity? Entity can be a person, place, event or an object that is relevant to a given system. Here you said employee, department, so these are all the entity. So, in that employee, so employee details is nothing but the attribute, means employee data's employee is a entity. So, F name, L name means employee ID, employee gender, everything is a attribute. So, that is what the entity. Next, weak entity. So, weak entity means it does not have primary key. So, a weak entity is an entity that depends on the existence of another entity. So, idli dependency irodrinda idakke weak entity anta heltivi. It is not a strong. In more technical terms, it can be defined as an entity that cannot be identified by its own. So, it is always it depends on some of the other entity. So, that is what it is a weak entity. It uses foreign key combined with its attribute to form a primary key. ಇದಕ್ಕೆ ತಂದೆ ಆದ ಒಂದು ಪ್ರೈಮರಿ ಕೀ ಅಂತ ಇಲ್ಲ, it always depends on some of the other entity or the attribute. So, that is what it is known as a weak entity. Yeah, here one ER diagram of auction system or the bidding. Yeah, here the user can sells n number of items, or n number of items is belongs to the single categories, or the user can place a n number of bids, or the single items can bid n number of times. So, this is what the ER diagram of auction system. So, this 1 to n, n to 1, 1 to n, 1 to n is a cardinality ratio, and this user, items, category, bids is the entity. Yeah, next is the validation. So, validation is a process of evaluating the final product to check whether the software meets the business needs. So, you have to check whether the software what you have introduced meets that business needs or not. So, that is a process is known as a validation, and it is in simple words test execution which do in our daily life is actually the validation activity that includes smoke test, functional testing, regression and the system testing. So, furthermore, due to nature of the requirement specification phase, there is a lot of room for misunderstanding and committing errors. So, this is what the validation. So, it is a process of evaluating the final product whether it meets the requirements or not. So, here there are mainly 4 things that we have considered regarding the validation, that is omission, incorrect fact, inconsistency and the ambiguity. So, what do you mean by omission? It's a common error in requirements. In this type of error, some user requirements is simply not included in the SRS. So, here there is a percentage of find outing the error percentage. So, this is a omission. So, and it is simple error or the error is in the requirement. So, that is what the omission. Inconsistency is due to the contradiction within the requirements themselves or due to the incompatibility of the started requirements with the actual requirements of the client or with the environment in which the system will operate. So, this is a contradiction within the requirement. So, this is a inconsistency. And the third common requirement error is an incorrect fact. The errors of the type occur when some facts recorded in the SRS is incorrect. So, this is what incorrect requirements. Now, collection of requirements alli yavadru requirements na incorrect agi choose madidre, that is a percentage or that may cause some errors. So, this is an incorrect fact percentage. And the last is the fourth common errors is ambiguity or duplication. Errors of this type occur when there are some requirements that have multiple meanings, that is their interpretation is not unique. So, ambiguity is nothing but the duplication or it is not unique. So, in this sort it may cause some of the percentage of errors. So, this is what the percentage regarding the errors while doing the testing. On the average, the total of more than 250 errors were detected and the percentage of different types of error was. For example, if we get 250 errors in some of the project, in that 26 percentage is belongs to the omission part, incorrect fact is belongs to the 10% and 38% for inconsistency and 26% for the ambiguity. The same thing in the errors detected in the requirement specification of A7 project. What is the project of which deals with the real-time flight control software. So, in this sort of project, you are reported a total of about 80 errors were detected. In this, about 23% were clearly in nature because of the weather. Bad weather iddaga some of the errors automatically barutte. So, that is of regarding the 23% of any nature, and the remaining distribution error, remaining of the error may cause omission is of 32%, incorrect fact is of 49%, inconsistency 13%, ambiguity 15%. So, this is what the validation and there are 4 steps regarding the percentage of errors you get while validating the problem. So, this is all about the SRS chapter. Thank you.